You know, when we think about history, our minds usually jump to the big stuff, right? Like wars and revolutions and huge turning points. But what if I told you that some of the most amazing stories are hiding in plain sight? Maybe even on a totally ordinary day of the year. Seriously, what if just one day, let's pick February 3rd, could secretly connect all the invisible forces that shape our lives? I'm talking about everything from the phone call you just made to the beautiful complex math behind a computer-generated image to the very radio waves that make modern life possible. Well, that's exactly what we're going to dive into today. So the date is February 3rd, and it's the strange thread that ties together three incredible minds whose lives just barely overlapped. First, we have Oliver Heaviside, who passed away on this day back in 1925. Then there's Agner Erlang, who died just 4 years later in 1929. And finally, Gaston Julia, who was born on this day in 1893. Now, these guys never met, but their stories are tangled together in the most fascinating ways. All right, let's start with a couple of real practical geniuses. I mean, these are the guys who built the invisible architecture that our entire connected age is built on. Okay, picture this. It's the early 1900s, and the telephone is just exploding in popularity, which is great. But it's also a massive headache for places like the Copenhagen Telephone Company. How many phone lines do you actually need? How many operators should you hire? If you guess wrong, the whole system just grinds to a halt. This was the exact puzzle that landed on the desk of a Danish mathematician named Agner Erlang. So what does Erlang do? Well, he basically invents a whole new branch of math called queuing theory. And yeah, it is literally the mathematical study of waiting in line. He had this brilliant insight that even though individual phone calls are totally random, the system as a whole follows these predictable patterns. He used a tool called the Poisson distribution to figure out the odds of a certain number of calls coming in at any given time. And the power of this idea is it's incredible. The formulas Erlang came up with over 100 years ago, we still use them today to figure out how to staff call centers, manage the flow of internet traffic, and even decide how many cashiers a grocery store needs on a Saturday. In fact, the international unit for telephone traffic is named the Erlang in his honor. All from this quiet, humble guy who died on February 3rd, 1929, and whose work, secretly organizes our world every single day. Now, just 4 years before Erlang passed away, on February 3rd, 1925, another giant of communication died, the eccentric and absolutely brilliant Oliver Heaviside. Now, Heaviside wasn't worried about people waiting in line for the phone. He was interested in the fundamental forces of the entire universe. See, when the great physicist James Clerk Maxwell first dropped his revolutionary theory of electromagnetism, it was a beast. I mean, it was this tangled up mess of 20 different equations with 20 different variables. Super powerful for sure, but basically impossible for anyone who wasn't Maxwell himself to understand. Heaviside, who was a self-taught former telegraph operator, took one look at this thing and basically said, nope, we can do better. He spent years rewriting the whole theory with his own methods and boiled that whole mess down to the 4 elegant, powerful equations that we now all call Maxwell's equations. That's right, the version every physics and engineering student learns today, it's really Heaviside's version. And this quote, it just perfectly captures who he was. He was all about what worked. He came up with this powerful new mathematical tool, but when the academics demanded he provide a rigorous proof, he just scoffed. He was like, look, it works, doesn't it? For him, the result was all that mattered, and that attitude kind of put him on the outs with the establishment for most of his life. And his practical genius didn't stop there. In 1902, he theorized that there had to be some kind of layer in the atmosphere that could bounce radio signals around the curve of the Earth. And guess what? He was totally right. We now call it the Heaviside layer, and it's the very reason long-distance radio is even possible. So just think about that for a second. 2 guys, Erlang and Heaviside, both linked to February 3rd, and between them, they laid the mathematical groundwork for both wired and wireless communication. It's wild. So we've got the architects of our connected world. But February 3rd also ties into a very different kind of story. We're going to leave the world of practical engineering and dive into a realm of pure, abstract mathematics that was born from an unimaginable horror. Our third figure, Gaston Julia, was born on this day in 1893. In January of 1915, Sub-Lieutenant Gaston Julia was on the front lines of World War I. He was one of the brightest young mathematical minds of his generation. And then, during a German attack, a bullet struck him right in the middle of his face. It destroyed his nose. The official report from that day is it's staggering. He couldn't speak, but he managed to scribble a note insisting that he would not be evacuated, that he would stay with his men until the attack was over. For the rest of his long life, he had to wear a leather strap across his face to cover the injury. So what does a person do after surviving something that horrible? Well, as Julia lay in a hospital bed, going through one painful operation after another, he found his escape. In between the surgeries, he did math. He created what we now call the Julia set. He was exploring what happens when you take a simple mathematical rule and just apply it to its own result over and over and over again. And the things that emerged, they are some of the most intricate, complex, and stunningly beautiful objects in all of mathematics. It was the very beginning of what we now call fractal geometry. At just 25 years old, while still recovering from an injury that would disfigure him for life, he published this 99-page masterpiece that won him the biggest prize in French mathematics. It is an almost unbelievable story of human resilience, of finding profound, ordered beauty in the middle of absolute chaos. So there we have it, our three figures all connected by this one day. Two who built the practical world we live in, and one who revealed its hidden abstract beauty. But here's the truly crazy part. This is just the tip of the iceberg. Yeah, it turns out that February 3rd is a weirdly, unusually busy day in the history of mathematics. The stories of Heaviside, Erlang, and Julia, it's not just a coincidence. They are part of a much, much bigger pattern. And the list, it just keeps going. On this exact same day, Carl Mollweide, the guy who invented a world map projection you've definitely seen, was born. Jean-Baptiste Biot, a pioneer in electricity, died. Émile Borel, whose work is fundamental to all of modern probability theory, also died. Pavel Urysohn, one of the founders of dimension theory, was born. I mean, it is just this extraordinary pileup of intellectual firepower on one single unassuming date. You know, it really makes you wonder. The connections we found for February 3rd, they're not magic. They're just a reminder that history is all around us, all the time, just woven into the fabric of our calendars. And it leaves you with a final thought. If a single, random day can hold the birth of fractal geometry and the blueprint for the entire internet, what incredible stories are hiding in the dates that matter to you?